I have two graphs. They're both parabolas, x squared plus 3x plus 1 and x squared plus 2x plus 2. I'm assuming that this is g of x, the dotted line one, and this is f of x. The reason why I'm looking at that is because the y-intercept of the f of x is 1, the y-intercept of the g of x is 2, so this one right here crosses this y-axis at a higher point than this one right here. Does that make sense? We cool with that? I didn't do anything crazy yet. Now what I want to figure out is, when is this equal to each other? When is f of x equal to g of x? Now I might not have been asked that question. Maybe I was asked the question, when is g of x bigger than f of x? And I would say in this region over here, that would probably be a good bet. Over here, g of x is bigger than f of x over here. But then I got to figure out, well, when do I tell it to stop? When do I say, well, g of x is no longer bigger than f of x at this point over here? Well, to do that, you would have to ask yourself, when is it equal to each other? So all I was asked this time around was, when is it equal to each other? But the point I'm trying to make is that even if I asked you, when is g of x bigger than f of x, you would still need to ask yourself, when is f of x equal to g of x? Now, when you actually look at the graph, I'll be honest with you, it looks very deceiving. It looks very, it's very hard to tell because those lines are so close to each other. Now, so what I'm looking at is, I kind of drew the graph a little bit deceiving. I made it almost obvious it's right there. But for now, if we only have a graph, what's nice about the graph is you can immediately look at something and say, oh, okay, this is the region where something is. But the hard part about the graph is, it's hard to tell exactly at x equals this that that's the case. You see what I mean? So I'm going to guess that x equals 1. That's where my thing crosses. And I'll be honest with you, if I only know how to use the graph, that's all I'd be able to tell you. I just say it's the best guess that I could give you. I can't tell you for sure when those two are equal to each other. I'm guessing 1. But you can do it algebraically. Let me show you how to do that. If I want to know when f of x equals g of x, what I would probably want to do, I'll erase some of this right here. Maybe I have enough room. Hopefully I do. Let's set this thing equal to this thing over here. So, because f of x is equal to g of x is really saying this thing is equal to that thing. So I've got x squared plus 3x plus 1 is equal to x squared plus 2x plus 2. Now all I want to do is I want to solve for x. I want to see if I can get an x value that will tell me when they're equal to each other. If I subtract x squared from both sides, those would just kill those things. Let's put everything that has an x on it, in it over to the left-hand side. So if I subtract 2x from both sides, I just get 3x minus 2x, which is just x. And then what I'm going to do is I'm going to subtract, you know what, I'll do it step by step for you. So I'm going to subtract 2x from both sides, because that kills it from going on the right hand side and brings it over to the left hand side. And I'm also going to subtract 1 from both sides. That kills this pure number on the left hand side because I want to shoot it over to the right hand side. So the 3x minus 2x is just x equals, this cancels itself out, this cancels itself out. 2 minus 1 is 1. Hey, I algebraically solved for what I guessed the answer would be. I said that it looks to me like x equals 1, and it turns out that indeed x does equal 1. So that's how you algebraically approach this problem. You happy with that?